Well, g'day champions, here's a bit of a strange one for us. Yeah, get your bloody mind out of the gutter, get your venereal disease jokes out of the way. This company, Crab Company, I don't know, I think it's a one-man show, but it's from Ukraine, of all places. Don't ask me how you can manage to build amps over there reliably with everything going on, but somehow he manages, and he does, let's say, inspired by other model amps. This one in particular being the Randall Satan. Now, as far as I know, the Randall Satan is a 120 watt take on the Diablo head from Randall, and it's the Ola England signature. So they tend to be going for about somewhere between 3,500 to 4,000 second hand. So this is like a budget lower power version of that, which is a cool idea. If only Randall did it. So anyway, one of my customers ordered this. He actually commissioned it off the bloke himself. He was discussing directly with the builder. Commissioned a one-off build. I think he builds to order. He may have a small stock, but generally I think he builds to order from what I'm hearing from the customer. And not too long a time later, this turned up in the mail. However, there was an issue. The foot switch was put inside the amp head, and you can see there's no rear grill on here, it's just open. Stuff shifted around in shipping, and the foot switch had smashed up all the valves, so unfortunately that wasn't properly secured. However, the builder didn't hesitate to send him a whole new set of valves, the whole lot. So we're going to try them out and see how they go. So we've vacuumed out all the glass. There's a few little bits still stuck to the foil tape there, so we'll clean off all the rest, give it a good brushing, but let's check out the amp. Well, we've got it out. There's every chance there's nothing wrong with it at all, but we'll just run an eye over it and check out the build quality and go from there. Before we do that, we'll check out the box. Now it's not a Tolex, it's like a vinyl. It's soft, it feels like there's a foam underneath it, like you'd find on like upholstery, like chairs and stuff. So I don't know how durable that's going to be. It feels like you could probably sort of scratch away at it with your fingernail, but if you take care of it, it should stand up rather well. Like maybe a cover's a good option for these. It appears to be solid timber. Looks like Baltic pine, which makes sense given the area that it comes from. You've got T-nuts for the handle, which is good. Little timber cleats on the front. Screw construction, which is good, not just staples and glue like some of the manufacturers do. It feels sturdy, like it's probably finger joined. Let's see if we can find evidence of that. Yeah, I can't make out because the paint's kind of thick. I can't make out exactly what join it is without taking the covering off, and we're not doing that. Front grille appears to be like 1.2mm steel, mild steel, powder coated. Looks laser cut. Yeah, you can see the lead in and laid out from the laser there, so that'll be a laser cut front grille, and it's got a little folded lip down the bottom. Very well done. Whoever's done this is not an amateur. This is pro work here. You can see little touches, like they put a little notch where they want to fold it, so it doesn't sort of pinch the metal there. That's the kind of stuff you see on pro metalwork. She ain't folded up in a garage bench vise. Now the logo appears to be, I don't think it's routed, but it's like the trophy shop type aluminium. It's black underneath. It's got a thin layer of metallic paint or whatever on the, or maybe electroplated on the front face, but it may be laser ablated. Hard to tell. I can't see any lines, which normally you would see in the laser stuff. Anyway, we're getting into the weeds, so let's have a look at the amp. So one valve was still intact and the other one was all smashed up. So just carefully remove that without putting glass through my hand. Interesting seeing the washer method on these Russian valves. So these are 6N3Cs, or whatever the N means in Cyrillic. Let's look up the data sheet. So they look to be new old stock. The getter's showing a bit of sort of aging that you often see, where it's not so much silver, it's got more of a blackened colour to it. So there may be some gassiness in them. We'll see what the replacement ones look like. So they're looking a bit better. I don't think this one's lost vacuum. Yeah, hard to tell. We'll see how they perform. As for the preamp valves, they're all in the original cardboard boxes, 6H2 whatever that is, and I don't know anything about this this writing. But we'll enter that. Surely some other dumbasses entered that in Google and got a similar result. So we'll see what we can find for the data sheet on them. I'm assuming these are Russian or ex-Soviet 12AX7 equivalent 6H2N. So we'll look that up. They look like a 12AX7 equivalent. 6H2N. It's got the same symbol. They look like a 12AX7. I don't know a hell of a lot about like ex-Soviet or Russian equivalents, like if they're a direct 1-to-1 or if there is slight differences that aren't super significant or you can adjust for. It would be cool to make like a direct comparison sheet if no one's done it before. However, I find that using the new old stock valves can be a bit hit and miss. You don't know what's happened to them over their life. They could be shipped around the world 3 times over by the time they get to you. And shock is not a valve's best friend. Handmade in Ukraine. Not the Ukraine, like some people say. No serial number, probably because it's a one-off build. Cool little symbol. It almost looks like something Blink 182. I don't know what the story is behind that. I'm maybe a dumbass. Definitely a dumbass. FX loop, foot switch. I've got a switch there that we don't know what it does. We'll have a look at it and find out what that's for. It's not... it doesn't have any labeling, so I guess that may be some factory setting that they maybe don't want the user to be playing around with. Otherwise, it'd probably print right there what it did. You got a low power, full power switch. I'm guessing that's probably a triode pentode switch. Got 3 impedance outputs, single jack per winding. Nice and simple, but it means you've got to be aware of what you're doing and not use more than one of them. And 1 amp fuse integrated into an IEC power input. Now on top we've got these ceramic sockets, which I'm not a big fan of because you can't really get into there and clean them very well. Sometimes even a toothpick doesn't make it in, and you can't really retension those contacts. So if they get fatigued, you kind of just got to replace the socket, which isn't that fun because you've got rivets. So you'd have to drill them out, put some screws in their place. But you know, you probably don't have to worry about that for another 10-20 years, so whatever. It's just... Often these things get distorted in terms of their significance because I am a repair tech, so I do this all the time. Whereas if you put your preamp valves in there and they last a long time, you only change them 2 or 3 times in the amp's life, it's probably not an issue. But people saying I'm whinging a lot because I find faults. Again, I don't know how many times I've got to say it. It's literally my job to do so. If this was everything's okay, everything's awesome channel, some of these people would be happier, but we wouldn't get much done, will we? I think a lot of people are conditioned by all the YouTube review shills where everything's awesome, everything's great, and then when they actually come to a channel that's, you know, based in reality, it's a bit of a culture shock to them. But anyway, go to those channels if you don't like it. Otherwise, let's carry on. We've got the same ceramic sockets. These actually aren't too bad. Some of them have so much play in this intersection that the keyway doesn't really work. And what I mean by that is you can literally put the valve in any orientation. And then when you pull it out, you might actually snap the keyway off because it is shoved right in there. But these are actually a bit tighter tolerance than your average ceramics. Generally, I like to go with the Beltons myself. Personal preference, but the Beltons molded to a much more accurate sort of die, whereas these, I guess with ceramic you probably have to allow a bit more tolerance for thermal expansion and shrinkage. You know, it can be a problem for all of us, particularly in the colder months. Again, we've got rivets there, so if you've ever got to change them out, it's a little bit more of a pain in the ass, but you just quote accordingly. But you can get in there and retension these contacts down in there, so they're not bad, and they're only about 2 mil below the surface, so they do hang on to the chunky meat of the shaft. Oh, fucking hell. Alright, there I go again. So we've got grommets there, which is good. A lot of these smaller builders forget all about grommets, and then you can cut through the wire quite easily with a bit of vibration. Toroidals are tightened nicely. It's good, and they've got a rubber washer on the top and on the bottom, so that's what you want. Can you remember recently on one of those Ashdown amps where they didn't use the rubber grommets on them, and that just made it cut through the insulation and hard short from the primary, from the power transformer primary to ground. So that was tripping the earth leakage detector, which was good fun. It does concern me a little that we've got pop rivets here for connection to ground on a powder coated chassis, I dare say. Why would you have 3 in a row? We'll find out when we flip it over. Looks like there is some provision for a choke on some models as well. Alright, so working our way over from the clean channel, clean, tone and level, so that's your master for your clean. Then you got a whole bunch of stuff, sweep, kill, select, so I guess that is changing your channels. Kill, no idea. It's probably the same functions as the Randall version, so I could look up what they do. Yeah, you got gain, girth, grind. Girth, I'm guessing, is like a, I don't know, would it be pre-distortion bass? And grind would be pre-distortion top end? Not sure. I have to look into it. I'll see if I've got the Randall Satan circuit floating around. We can see, like, electronically what all this shit does. We can also refer to the Satan manual as well. I don't really want to trace this circuit out. I don't have time. Then you got a normal 3-band EQ, bass, middle, treble, and a sweep switch here, which is a 3-position. Then you got your master for the dirty channel. So there's no master. There's no overall level control. You just got to adjust individually on each channel, which is fine. I actually kind of prefer that, to be honest, because that gives you the freedom to have a clean channel that you can sort of push into a bit of overdrive as well. If you've just got clean and tone, and the clean channel's always clean, like it always has headroom, then you kind of don't need that, because your master is basically the clean channel. But that means that if you do have a clean channel that can venture into like a bit of crunch, then you kind of want a master as well. So your master section just has presence and depth, so that's negative feedback stuff. We all know what they do. Well, we should by now. Front panel looks to be printed 0.5 mil aluminium, like maybe UV printed. It's funny, it almost looks like, remember the old inkjets, the photo paper, but it's got a perfect gloss to it, so I'm not sure what it is, if it's a film or what, but it's so thin. Like, it looks almost the thickness you'd expect from anodizing. So yeah, some sort of print process, but it looks good. Just flip her over and have a look at the guts. Alright, so this is pretty much how I'd assemble an amp. Try and keep your wires as short as possible to the socket. Do all your serious work on the PCB. Through hole plated PCB. Pretty thin traces though. I'd like to see a bit chunkier pads and traces. Just for serviceability, you know. My personal preference. Some mods here, so maybe they might have a sort of circuit board they use for several different versions, and they populate it to suit each version. Decent looking relays. They look to be hermetically sealed. The little thing there that's normally a vent has a little plug of glue or whatever in it. What caps have we got? I'm expecting to find some weird brands in here that I've never seen before, and HY brand caps is one of them. So you've sort of got a preamp board here, then you've got a phase inverter and power supply board here with all the filtering. Alright, so I kind of like how this is done. You've got a board here which is your power supply. Look how tiny these caps are these days. They're 33 microfarad, 500 volt. Then you've got two lots of series caps here, 100 microfarad 250 volt, 100 microfarad 250 volts. So that's your first two nodes. Then you've got your phase inverter node over here, and your phase inverter is hidden away under this effects loop board. And then that goes off to the preamp board, which could be any number of configurations, I'm assuming. Yeah, you got some local filtering on the preamp board as well. They're just, what, 10 microfarad, 450 volters. So down on the front here, we've got PCB pin pots that just have tack soldered components. Not a hell of a lot we can do about that other than redo all the connections or replace all the pots, but they are what they are. They'll probably be sturdy enough. It's pretty light gauge wire. A little bit... Everything just feels a little bit light gauge on this, so hopefully that's not an issue. But I'd like to see that lifted up from the board a bit too, which we'd have to replace if we want to do that, because the lead's already too short. So everything's laid out rather well. Just the wire feels a little bit... It's almost like it's like silicon. It's real wispy, soft, almost rubberized insulation. Feels like you could probably almost put your fingernail through it. Down here you can see the little bias supply. It's got provision for even more pots, so maybe they're adjusting bias per valve, because you can see for a 4 output valve system here, they may populate those two outer trim pot footprints as well. I've got a tiny little bridge rectifier down here, not sure what the rating is on that. That is a DB107, which is a forward current 1 amp peak reverse voltage 1000 volts, so it's like having a bunch of 1N4007s. So moving on, have a look at the output section. So that switch on top is to suit different heater configurations for the preamp valves, whether they're 12 volt or 6.3. Maybe that's because the new old stock valves they're using in these are like 12 volt only, like they don't have any connection to pin 9. I'll have to check the data sheet. Got 1 ohm current sense resistors to ground. They can also double as a sort of fuse if you're probably not at that power rating, but that to me looks like a 1 watt carbon film, maybe a 2 watt actually, pretty large. And then you've got what we suspected here, which is a triode pentode switch, and you've got some 470 ohms to the screen. Got a little circuit board there for the speaker outputs, very cute. Everything's reasonably sturdily built, just everything just feels a little bit light gauge, but you know, it's probably fine. What I'm not a huge fan of is always, champions, I will harp on about this shit until the heat death of the universe. If you're going to get one connection right in your amp, it is this one right here. That's your main safety earth. And in this case, they've used that wispy ass wire again. They've just tack soldered it, not gone through the eyelet. So I'll replace that with some proper approved wire, proper color code as well. And we'll get rid of that rivet down there, and we'll put a proper screw with a tooth washer and an eye lock nut. At least they have scraped away that area in the powder coat, which Mesa Boogie still haven't figured out. And look, that's the case for every ground in this amp. They're all pop rivets, non-toothed washers, very light gauge. And then just onto the steel chassis that's had a little bit of paint, or looks like they put a bit of tape over it prior to the powder coating process, just to leave that area raw, which is the way you do it. Down here we've got another ground again, no tooth washer, it's just a flat washer with a tab coming off it, sort of. And no tooth washer to the chassis down there, so nothing really biting into that metal. Same goes up the front end there. You've got a couple of unused ones, but the main signal ground there. Your effects loop and your foot switching here, it's interesting. It has some unpopulated parts here. Looks like they have a reverb option on some of their models too. You can see to reverb tank, trimmer, reverb gain. So these unpopulated areas here is the reverb circuit. And it looks like here they're probably using a TO220 type device for the reverb drive, which is one way of doing it. Instead of using a transformer, that'd be solid state drive with a high impedance tank, or medium impedance maybe. It's all just speculation, champions. The little daughter board, that's not a bad way to go. Again, the traces are really tiny, and the pads are really barely bigger than the hole itself. This is sort of how I play it on mine. I make the traces as fat as I can, and the pads are barely smaller than the trace. Because I've ripped a lot of pads out of stock amps in my time. There's probably somewhere I could grow a bit bigger on the next revision. Maybe the transistors go elongated pads so we can get them sort of oval or rectangle, get some bigger surface area there without getting too close to our margins. But generally, yeah, I just try and keep the pads as large as I can, the traces as large as I can without impeding the layout too much, making it too difficult to keep your margins. You see on the bottom, same deal. Anyway, like I said, we're not going to trace this thing fully out. We're just doing an inspection to make sure there was no other physical damage in shipping. Then we're going to fire up those new valves and just get them all matched up. And up the mains end there, we've got a voltage selection switch, which isn't accessible unless you pull a chassis from the cabinet. And it's set to 230 actually. Well, what's written there anyway. We'll see how that relates to the heater voltage. So anyway, I'm not going to go mad tracing this thing out. We're basically the brief is to just make sure there's no other damage in shipping and just make sure the thing's stable. Put in those new valves that they supplied and bias them up. So we'll do that. We'll take down various measurements as well, just so we've got a sort of data set of where this thing's at the moment. And if anything changes in the future, we'll have that to refer back to. Now you can see all the holes on the front of the chassis there. I'm not sure, they're offset with the knobs, so they must be, yeah, well you can see the switches are lined up there, so that's all the different options they could have on the various different models. So I kind of like the way they've done that, because it sort of makes the one chassis which you can stock up on and order in bulk, get the pricing down, but then you can use it for all different models, which is sort of the best of both worlds. If I get into manufacturing, I'm going to probably do a similar thing. When you're a small outfit, you sort of need to do these kind of things wherever you can to save a bit of cash, get some bulk orders in without compromising quality. And that's how you do it. Not a big fan of just using the thickness of the sheet metal to tap a thread for the mounting screw there. Not a lot of meat there to grab onto, and if you over tighten that, you stripped it. And about the only thing you could do then is put in a threaded insert, like a rib nut or whatever you guys call them. We call them nutserts. But then you don't have a lot of size here, and often you'll have to drill like a 8mm hole to fit a 5mm nutsert. That'd be an M4 by the looks of it. So you might have to drill like a 6mm hole, which would get you pretty close to that shoulder there. So have to be careful tightening that up and just not knock the amp around too much. Alright, so all the valves went in. The sockets are nice and firm, good tension on the contacts. There is no retaining mechanism for any of them, including the outputs, but just don't juggle your amp, don't kick it down the road to the gig and you should be right. It is a head, so it's upright, they're not trying to fall out. There's quite a few solder connections I want to touch up, critical stuff like the heaters, cathode, plate. We'll just re-terminate them and solder them to my picky standards. No real great test points. As a tech, I try to install test points in my amps. Maybe even like turrets that you can just hook your meter onto. But often there's no consideration of that. These guys aren't alone in that. Pretty much no one does that. But you can always tell an amp built by a tech because it'll have dedicated test points which are easy to clip a lead onto, that kind of thing. But what you can do is little tricks like this. Get the IC lead onto there, and then put another IC lead onto that IC lead, cross them over. That way we've got two monster terminals and one tiny little leg. Just going off the primary of the output transformer, we've got 30.6 ohms on one side, 33.6 on the other. So we'll go, say, 31 and 34, round it up, because it does increase a little bit as the amplifier warms up. We'll use that resistance to sense the anode current and calculate it. You've seen it a million times before, but it's just a good way of measuring the actual plate current without modifying the amp, without using dodgy bias probes or fucking around putting resistors in series using the shunt method. You can just use the resistance of the primary of the output transformer to determine your plate current directly. Or you could use the pre-installed 1 ohm resistors down there. Always check them for resistance before using that method, however, in case one's drifted out or been damaged by a shorted valve, that kind of thing. It can drift wildly in value. But that will include the screen current as well. So you just factor in 3 to 5%, something like that, and then bias it to suit, or just bias it a little bit on the cooler side, taking that into account. And now my phone's ringing because I pressed record on the fucking camera. Alright, so looking at the specs on these, it's tempted to treat them like a 6L6, but or a 6V6, because that's our sort of go-to valves here in the West, but it's actually got its own specs. So the maximum anode dissipation is 20 watts. So say we're going 50%, we want 10 watts, maybe 12 watts if we're going a little bit further. So that's what we're aiming for. We can use the primary resistance of the output transformer to calculate the anode current, multiply that by the plate to cathode voltage, and that will give us the actual dissipation, quiescent dissipation. But this ain't a teaching channel. There's plenty of other resources available for that are much better at articulating it than I am. So let's just carry on, shall we? 12 watts. Let's aim for 12 watts. Alright, so the standby switch on this one turns the AC off completely to the HT, but we still have a low voltage negative winding there for the bias supply, so we can check that we've got bias minus 49 or minus 50 on one side, minus 52.3 on 52.2 on the other side. So that's been adjusted to suit the previous valves. We'll see how these ones sit. So I still haven't taken it out of standby. I'm just going to adjust those grid voltages as negative as possible first, just to see where these valves sit. It's a safer way of doing it. It does mean that the voltage won't sag down as much though, so we'll have to just check how close that is to the cap ratings and whatever. Those pots are pretty twitchy. They're going to be fun to adjust. It's better to have a slightly larger handle, so you've got a little bit of angular accuracy there. Alright, we've got 470 on the plates there. The absolute maximum anode voltage on those valves is supposedly 375 according to the data sheet, so a little bit hot there. Alright, champions, so we're sitting at around 468 volts on the plates there, and say when we wind them up we're aiming for about 450. You've got to do a bit of guesstimation here. 450, the voltage will maybe sag too. If we pull these up to about 0.9 of a volt, then that's our 12 watts that we're after. So let's just see how that reacts. Alright, very twitchy on the pots there. So we've only sagged down to about 465. We'll take it easy with the current there, because it's not going to sag as much as we thought. We'll recalculate and assess from there. So remember, we're aiming for about 0.9 of a volt on both sides, considering the DC resistance is pretty close on both sides of the windings there. About about 0.9, down to 457. So what's that? So 0.9 divided by, say, 33 ohms, 27 repeater milliamps, multiplied by 457. So we're sitting at 12.5 watts. So that divided by 20 watts is 62%. So I'll be pretty happy with that. So that voltage is still like 75 higher than the data sheet recommended maximum, absolute maximum. But you know, everyone else does it, so why shouldn't we? Alright, so I'll give that some signal. Have a look at the signal through the scope. We'll put it under load for, I don't know, 20 minutes or so, and just check that everything's still stable with those new valves. Just check that nothing's drifted. A new set of valves, or one that hasn't been burned in yet, like even if they are new old stock, you generally find the plate dissipation just goes up a little bit over the first 20 minutes, half an hour of idling. So we'll let it sit for a bit, and then we'll readjust, and then we'll do some sound samples, see what this thing sounds like. Alright, so she went up a little bit to about 1 volt, 1.1 per side there on the DC drop on the output transformer primary. So I pulled that back to just under 900 millivolts, and she's nice and stable. Let's give it a run and see what it sounds like. So I'll take some measurements, note them down, then we'll put it back in the cabinet and give it a bit of a sound test. Tune out if you don't like really poorly played genty riffs. Alright, champion, so I could go through and do every ground in the amp, but I decided, look, there's going to be people that say, oh, you worry too much, why are you redoing that ground? And there's going to be other people that say, oh, you redid every ground, what a rip-off, you didn't have to do that, whatever. At least I thought we'll change this safety ground. We'll put a proper nice gauge wire in there instead of the sort of flimsy stuff they had in there by stock. And we'll put the proper toothed eyelet terminal down there with a flat washer, a spring washer, and a nylock nut, and they're all stainless steel. And I got the Dremel out and cleared the powder coating off a little bit further from that area. And that's the speaker ground for the secondary of the output transformer. I thought, let's give the other sturdier ground too. A better current carrying capability on that heavier gauge wire. It can't hurt. And if there's any issues with the other grounds on the chassis throughout the amp, we could deal with them as they occur, because they're not as critical as these connections here. So this is the wire that was that ground connection. It's really wispy. Looks like maybe 24, maybe even 26 gauge. So yeah, you don't want to be relying on that for the safety ground or the speaker ground with its high return current. Oh, there it is right there. What's it say? 26 gauge, 200 degrees rated. So it's been 200 degrees rated. It's probably silicon, which is probably why it feels like that. But I'd like to have a heavier gauge wire for the safety ground in particular. And I thought, well, we're there, we'll do the speaker ground as well. Alright, champions, let's have a listen to this thing. We're on the clean channel. We've already noticed a few weird things. Like I said, we're not reverse engineering or, you know, rebuilding this thing. I'm just giving it a service and a check over. But anyway, you be the judge. We'll take it to some crazy, silly settings and see how she performs. A lot of the times, amps can perform fine with everything at 12 o'clock or, you know, the middle of its settings. But if you take things to extremes, things can get unstable. That's sort of an idiot check I do to my own amp design. Some amps like Mesa Boogie and stuff don't like to be taken to their extremes because they oscillate and do all sorts of weird shit. In my opinion, you shouldn't be able to make an amp do something, you know, untoward no matter what the settings. It should be stable no matter what crazy shit you set it to, because guitarists or artists, they take things to the extreme. They try to look for new sounds, and you don't want your amp to oscillate and blow up its output stage in the process. So anyway, let's have a listen and see what happens. Alright, so kind of strange behavior there on the clean channel. It seems to work best if you turn the level all the way up and pretend that there's no volume control if you want crystal clean, and then use the clean just as literally your volume like you would on a non-master volume amp. It does lots of strange stuff when the tone's all the way down, and the tone sort of goes full range from like 1 to 2 or 0 to 2, and then doesn't do a hell of a lot for the rest of its range. So I've got a feeling it might be the wrong taper pot there. Like I say, without reverse engineering the thing, there's not a lot you can really glean from it. So I'd be using, if you want crystal clean, I'd be using it sort of about here, and then using the clean gain controllers, like the volume for the clean channel. However, it does get a bit crunchy if you pull it down sort of to about this area, so I'll have a listen to that. Don't mind a bit of hum there. That's just with single coil pickups picking up a bit of hash. But you know, it does have a nice, pretty smooth overdrive when you use it in that manner. So I'll just grab a humbucker guitar and we'll move over to the dirty channel. Just before we go over to the overdrive channel, I'll just try some humbuckers on the clean channel. But the main reason people buy these things is the overdrive channel, so let's try that out. So there you go, champions. A pretty nice sounding dirty channel. Anyway, champions, just thought you might have a quick look at this one. I like doing the videos on the sort of amps you don't see every day, and this is one of them. So props to the builder for producing something to this level with everything going on over there, fighting the good fight. It's quite impressive. So keep your head down. I hope you stay safe, and I hope you keep producing for a long time. If you want to reach out and say g'day, I'd appreciate that too. I love doing my part to maintain a bit of a network globally of people in the trade, and you know, share information if we need to, you know, refer people to local techs we can trust, that kind of stuff. I'd like to extend that as far as we can beyond just the Australian, the UK, US. Anyway, thanks for watching, champions. Give it a thumbs up. You know, the usual jazz. I'll see you on the next one. We'll get a cream to clear up those crabs.